Hi, Louis.
Hello.
Just getting situated here. Sorry, I'm just trying to figure out what I need to do. Okay, how's it going, guys? I got 1, 2, 3, 4, 5 of you. 6 now. Okay. Nope, that's not what I want. That's what I want. How we doing, guys? We doing okay?
Doing good.
Good. Basically, what this lab is it's kind of a review. It's kind of like throwing a little bit of new stuff in there. And basically, the best way I know how to do this particular lab is to do it in a workshop format. Okay? So that's basically what we're going to do to get through this particular lab. All right? Now, having said that, we have to deal with Dr. Musgrave's format. So the first couple problems I'm going to be dealing with, I'm going to be actually using the quiz that you're dealing with. And I am going to use that to try and show you how you need to fill in the format. After that, what's going to happen is we're going to work it. We're going to be working it problem by problem, okay? And I probably won't go beyond an hour, but I'm going to be here just as long as you need me to be here. So is everybody seeing the screen labeled Dimensional Analysis Quiz?
Yes.
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 Okay. So did anybody have problems with this the last time? I believe it was the mole. I believe it was the mole lab that he did this. Did anybody have any real problems with it? Maybe I don't need to do this then. Okay. Basically, guys, what you're going to have to do, there is a position up here, or two positions actually, 1 and 2. And you have to show how you're going to go from grams into moles of N2. Simple enough, guys. And you're going to have to choose one of these choices to put it in the 1 position and another one to go in the 2 position. So looking at this problem, 100 grams of nitrogen. By the way, ladies and gentlemen, I am recording this, but you will not see this for a week until after you publish the results from this. Because the second thing is, I do not want you to sit there with the computer on. I don't want you actually putting the numbers in. I would like you to try and do these problems. Okay, having said that, can somebody tell me what you think needs to go in the number 1 position?
One more and 2.
So I'm going to come down here. I'm going to find my choice, and I'm going to put that in position 1. Now I've got 1 mole on top. What's going to go on the bottom?
28.02 grams.
the 28.02 grams. Now, for the life of me, I cannot fathom why he's making you do this, but he is. And if you don't put an answer in for every possible answer, you're going to get it marked wrong. So everything that you don't put an answer for, you're going to have to come over here and see that they're unused answers. Done with problem 1. Okay? We're going to go down to this one. Okay, we got half a mole of calcium phosphate. I want to know how many grams that is. So what's my choice for putting in position 1?
1 gram.
1 gram? What's 1 gram going to be equal to? How many moles is 1 gram of calcium phosphate equal to? Remember, when we're doing this, this is our known, and this is what we're trying to solve for. So we're going to have to go from moles to grams. What's the label that's going to go on top?
310 grams.
Thank you very much. It's going to be the 310 grams. We're going to need to put grams on top, and we're going to need to cancel that out with moles on the bottom. So if 310.18 goes in position 1, what's 310.18 equal to? How many moles?
1 mole.
So we're going to put the 1 mole calcium phosphate in the 2 position. Everything else we're going to label as unused. Any questions about this? Questions, guys? Do you feel fairly confident to do this?
Yes.
All right. Okay. First problem we have here with stoichiometry. And this is really where I want to concentrate because that's kind of where I am in lecture. Okay. I am starting with 150 grams, and the question's asking me how much fluorine can I make? I'm sorry, excuse me, my bad. If I have 150 grams of aluminum, how many grams of FT is it going to take to react with all that aluminum? So the way I teach stoichiometry, I teach it in terms of 3 steps. First step, turn your grams of known into moles of known by multiplying it by 1 mole over the molecular weight or atomic weight. Second step, you look at the chemical reaction and you look at the coefficients in front of your particular compounds. You look at the coefficient of your unknown, put that over top your coefficient of your known, because what this particular equation is saying, I react 2 moles of aluminum with 3 moles of fluorine. So when I put 1 mole over the atomic weight of aluminum, grams of aluminum cancels with grams of aluminum, I'm left with moles of aluminum. I then figure out my molar ratio. That would be the coefficient of the sample we want, which is the F2, divided by the coefficient of the sample we want to get rid of. Finally, last step, I've now got moles of my unknown. My last step is I need to take moles of my unknown, create grams of my unknown by multiplying by the molecular weight over 1 mole. So, what goes in position 1? Remember, first step, we're trying to make moles of aluminum.
1 mole of aluminum.
All right, you notice I got 2 choices here. I got 1 mole of aluminum and I got 1 mole of aluminum, parentheses 2. I suspect that either one would work. However, do the safe side. The first time you use a particular answer, use the one without the parentheses 2. So I'm going to call this one my position 1. Okay? I need to equate 1 mole with a certain amount of grams of aluminum. What is that going to be?
26.98 grams aluminum.
So that's going to go in position 2. All right. All right. Now I've figured out my moles of aluminum. What is my molar ratio? Looking at the equation.
2 to 3.
Okay, 2 to 3. What goes on top, the 2 or the 3?
The 3.
3 moles of what?
Is that fluorine?
Fluorine. So I got 3 moles of fluorine. That's going to go in position 3. What's going to go in position 4?
2 moles Al.
Okay, fair enough. Now I've canceled out my moles of aluminum. I now have moles of fluorine. I want to get grams of fluorine. So what's going to go on top? And what's going to go? What am I canceling out here?
Moles.
And what am I trying to get?
Grams.
Is there a relationship between moles of fluorine and grams of fluorine?
1 mole is equal to the molecular weight.
Which is
38.
38. So what is going to go on the top here? What do I want to end up with? Go ahead.
The 38 grams of fluorine.
And what is going to go on the bottom? $38 grams of fluorine is equal to
1 mole of fluorine.
and again, and believe me, some of these are going to be a pain in the butt. Now, here's another thing, guys. You're going to get used through the first bunch of problems. You're going to get used to saying, oh, number 3 is the unused answer. If you keep on entering number 3 is the unused answer, that's going to mean all these are wrong. In this particular case, 7 is my unused answer. Okay? And that problem is done. Any questions on how to actually do the quiz itself? Does it make sense to you now? We good with it? Okay. Because if we're good with it, we're going to go back and forth and do a couple stoichiometry problems. Okay. It's going to take a few minutes to load this up, or maybe not. Okay, we're going to concentrate. Again, what happens is the first problem set, the first 8 problems are nothing more than converting grams to moles, moles to grams, grams to molecules, molecules to grams, and moles to molecules, molecules to moles. That's what you're doing in the first 8 problems. The second 8 problems, you are doing stoichiometry. The last one are very, very difficult dimensional analysis problems. They also, the quiz will take up the moles and it will take up the stoichiometry. That is what you're actually getting graded on. These last 8 problems, dimensional analysis problems, are extra credit. You can work them for some extra credit. Okay. I'm going to try and make it. No. Okay, first problem here. Find the mass of water needed to react with 150 grams of potassium. So, I go to the very bottom here. Okay, new slide. Okay, my equation. I've got potassium reacting with water to make.
Oh, we don't see the PowerPoint if that's
Oh.
what you have on.
Thank you. Thank you very much. So I need to make sure I'm not screwing something up. Yep, I was right. Okay, so I'm going to go to the. Are you seeing the PowerPoint now?
Yes.
That is my reaction. It's not balanced. Okay. I'm going to need to put a 2 in front of there, 2 in front of there, and a 2 in front of there. All right, guys. That seem balanced to you? Looks good to me. So my problem says how much water reacts with 150 grams of my potassium. All right, are you seeing the slideshow yet?
Yes.
Okay. Remember, 3-step process. Find my moles of known using the molecular weight of the known. Second step, determine the molar ratio between your known and unknown to get the moles of your unknown. Then multiply your moles of unknown by the molecular weight of your unknown to get grams. So come on, what are we doing here? First step, what are we doing? Mariah, go ahead.
We do 150 grams of potassium multiplied by 1 mole over the molecular weight, which is 39.098.
I like 1 0 better. Okay. Am I bereft of a calculator? Well, the one I had here was crap anyway. I'll be right back. 3 seconds to get a calculator. Somebody done the math yet? You get that board? Nobody did the math?
3.83. I mean, 3.84.
Sake figs. Technically speaking, this is only 2. It may have, he may have put a period there. So we're going to use 3 for right now. We're going to assume that this is that much grams. So we have 3 sig figs. Okay. I got 3.88 moles potassium. Okay. What did I say? The next thing we do is
Find the ratio
Moles
between
per
the two.
volume,
what is that molar ratio?
2 moles or 2 of H2O moles over 2 of potassium.
So I basically get my 3.88 moles back. But in this case, it's now water and not moles of potassium. All right. What did I say we did to get our last step? We want grams of water.
3.88 moles of H2O times the molecular weight over the what is
What are
it?
we
We're
trying
going
to get-
to
what are we
grams. Are we
trying
going
to
back to grams?
We're going from
Yes.
moles of
Okay.
water to grams of water.
Okay, yeah, the 1 mole on the bottom.
And the nice thing about this lab, guys, is he gives you the right answers. And so I got 69.9. Again, 3 steps. Turn grams of known into moles of known using the molecular weight. Take your moles of known, turn it into moles of unknown using the molar ratio. Third step, take your moles of your unknown, multiply it by the molecular weight, you will get your grams of unknown. Any questions here, guys? Questions? Okay, let me see if I can copy this and paste it. No. Okay. New slide.
Could you do like number 6 or 7 problem where there's 3 compounds involved?
Okay. Be happy to do anything you want. Can you read it for me? If you read it for me, this will go much faster.
Okay. Find
Give
the
me
mass.
give me the chemical formula first. The chemical equation.
Sure. 4NH3 plus 5O2. Reactant, or the products is 4NO plus 6H2O.
Okay, and the question is?
Find the mass of nitrogen oxide, is that it? That could be produced if 100 grams of ammonia reacted with 100 grams of oxygen. And what is the limiting reactant?
Okay. This is a limiting reagent problem. I know that because I'm given an amount of one reactant and I'm given an amount of the second react. I'm sorry, does it react with O2? 100
Yes.
grams of ammonia is reacting with 100 grams of O2, correct?
Yes.
Okay, so I have an amount of the first reactant. I have an amount of the second reactant. Again, immediately looking at the problem, if you see that, you know you have a limiting reagent problem. You're going to run out of one of your chemicals. When you run out of one of your chemicals, the reaction stops. And whatever you've produced to that point is the amount that you produce, and that's what you report out. So how do we determine that amount that's produced? Well, I'm sorry, it's asking, yeah, mass of NO. Well, basically what it's asking is, if I have 100 grams of NH3, how much NO can I make? If I have 100 grams of O2, how much NO can I make? And then once I determine that, I can compare the two numbers. The one that produces the least came from the limiting reagent. That is the one, that's the amount we report out. So basically, we have to do two stoichiometric problems. I'm going to start with 100 grams NH3. What was the first step I said we did?
Mole, 1 mole over the molecular weight.
You're exactly right. We need to change this into moles. So we have to multiply this by 1 mole divided by the molecular weight of ammonia. I do this out. And I get okay. Now I got 5.78 moles of NH3. What did I say the second step was?
Moles of unknown over the moles of the known.
We get that by applying the molar ratio. What is the ratio of NH3 to NO?
4 to 4.
4 to 4. So what this is saying is, if I start with 100 grams of ammonia, I'll make 5.78 moles of NO. All right, let's work with our second reagent. I got 100 grams of oxygen. Remember, stoichiometry, first step. What do we do for the first step?
1 mole over the atomic weight.
Oh, I have a dilemma here. Do I use 16 or do I use 32?
32.
All right. If I want to stop here at this point just to make a point for you. when you were doing empirical formulas, you were finding the molar ratio between the atoms. So when you were doing that, you took the grams of oxygen and you divided it by 16, which is the atomic weight of oxygen. We're now doing stoichiometry. And when we're doing stoichiometry, we are interested in the moles of O2, the molecule O2. So when we're doing stoichiometry, we use the molecular weight of O2 of 32. Empirical formulas, we use the atomic weight, which is 16. Does that make sense to you all?
Yes. Yeah.
Okay, first step accomplished. I got moles of O2. Now, what is the next step I need to do? Stoichiometry. I find the moles of my known. Now what do I do?
Find the ratio.
What is the ratio?
Let's hear 5 to 4.
What goes on top here?
4 would go on top.
All right, ladies and gentlemen, I found out that 100 grams of ammonia will make 5.78 moles of nitrogen oxide, nitrogen monoxide. 100 grams will only make 2.50 moles. Right after you do the molar ratio step, you can compare moles that are produced by one reagent versus moles moles made by the other reagent. When you get to this step, you figure out which one is smaller. Which one is smaller, guys?
Oxygen.
2.5.
I'm sorry? I heard Ali say, or I heard Mariah say oxygen. Ali, did you say something?
I was saying the 2.5 moles of
Okay.
NO.
So my limiting reagent is the oxygen, and it only produced 2.50 moles. So my last step, I'm going to take my 2.50 moles and multiply it by 30.01 grams per 1 mole. And this will give me 75.0 grams NO. Now, you may ask me, why didn't I bother determining the grams of the NO made from NO3? The reason I didn't is I'm simply multiplying by the same number. So do you see that I'm just multiplying both of these numbers by the same molecular weight of my product over 1 mole? Are you seeing that? I'm just trying to save you a step, that's all. If you want to go out and do this, you're certainly justified in doing it. And then you can look at the 75 versus 173, and you know that the 75 is smaller, so that must have been produced by the limiting reagent. But since I'm multiplying my moles of my product by the same molecular weight over 1 mole, I can use the moles to determine what my limiting reagent is. Make sense, guys? So
Yes,
this,
thank you.
this is my preferred answer. Do we want to do another one? Let's do this one. And I'm going to need somebody to tell me what the equation is and what the amounts of each are. Okay, the equation. Somebody read the equation to me. Guys, if you can't even read the equation, come on.
Which question were you looking at?
I was looking at the 3 KCl, question 7.
Plus 4 HNO3
Thank you.
products 3 KNO3 plus Cl2 plus NOCl plus 2 H2O.
Okay. Now read the other part of the problem.
How many grams of fertilizer can be made from 735 grams of KCl reacting with 110 moles of HNO3? Which is the limiting reactant?
Okay. So it just says how many grams of fertilizer?
With 110
Okay, okay.
moles.
It identifies the fertilizer as KNO3.
Yeah.
That little part you left out. Okay. We can do this. What's the first step? Sheridan, you haven't answered anything for a while. What's the first step we've been talking about?
The first step,
First step.
it would be to find the mole for the KCl.
Find the moles. First step, find the moles of the KCl. So I got 735 grams. Sheridan, how do I get moles out of this number of grams?
You would put the you would put 1 mole on the top and then the molecular weight on the bottom.
Okay, so I'm going to get 735 and I'm going to divide it by 74.55. And this is going to give me 9.86. Okay, somebody. Where do I go from here?
For molar ratio,
Molar ratio. What is that molar ratio, Allie? What are we trying to make, Allie?
3 to 4 is the ratio.
I'm sorry,
3 to 4.
what are we trying to make?
Find the grams of fertilizer.
Which is,
The KNO3,
so what number's in front of KNO3?
3. So 3 over 3.
So 3 is in front of the potassium nitrate, 3 is in front of the potassium chloride. So I got, in order to get the moles of, no, we don't want to do 33. I'm going to take 3 moles KNO3 divided by 3 moles KCl. So I have 9.86 moles of KNO3. All right. Now what do we do? I got 110 moles of nitric acid. Trick question here, guys.
Do the molar ratio?
Mariah, what'd you say?
Do the molar ratio?
But you're not changing grams into moles.
Oh.
Mariah, don't back down. Stand your ground, Mariah. Do you already have moles, Mariah?
Oh, yeah.
You already have the moles, so you don't have to turn grams into moles. You already have it. So I've got 110 moles of HNO3. Now, Mariah, what is that molar ratio? Come on, Mariah, what's the molar
Oh.
ratio?
Sorry, I was trying to find the NO3. 4 to 3. But
Okay, what
3
goes
on
on
and
top
4
here?
on the bottom.
What goes on top?
3. Oh, this is the one I meant by the molar ratio. Was this, not to grams?
I'm sorry, I didn't understand the question, Mariah.
Never mind. It's fine.
Okay. Which one is the one that came from the limiting reagent?
$9.86.
So the 9.86 is the one that we're going to use to determine now what do I do here? I got 9.86 moles of potassium nitrate. What am I doing now?
Go to grams.
So I'm going to take my 101 and multiply it by 9.86. And this is going to give me questions, guys. Questions. I'm getting a certain lack of enthusiasm here, guys.
I just want to make sure this is right. That 101.11, that's just the weight of the KNO3, right?
That's the molecular weight.
Okay,
Potassium,
good. Just want to make sure.
potassium weighs 39.1. You add to that the 48 from the oxygen and the 1 nitrogen at 14.01. Add all that together, you get 101.11.
Cool, perfect.
Guys, I'm here for you. I am here for you right now. What are you not understanding about stoichiometry? Or you got all this crap down solid and you don't need me anymore. You can just throw Mr. Popovich on the rubbish pile. Some would do it like with great fervor.
So the 9.86 is limiting just because it is smaller?
Yes, you ran out, okay? So what happened is the 9.86, okay? The 735 kept on producing KNO3, kept on producing KNO3. Then we ran out of the KCl. We still have more of the HNO3. There's more HNO3 that could react, but we have no KCl. If we have no KCl, the reaction cannot go forward. The best way, the best analogy I can do with this is you have 36 slices of ham and 28 slices of bread. Okay? Your chemical equation of this. You need 3 slices of ham and 2 slices of bread to make sandwich. Okay? How many sandwiches can you make with 3 slices of ham?
12.
You're taking the 36 slices times 1 sandwich. Again, look, I am using my coefficients here. Right? On the other hand, with my bread, okay, the bread will make 14 sandwiches, but I only have enough ham to make 12. So how many sandwiches do I have?
12.
12. I have 12 sandwiches. So basically, I kept on putting 3 slices of ham. I put 3 slices of ham on 12 pieces of bread, covered them with another slice of bread so that I had 12 sandwiches. I have 4 slices of bread left over that weren't used because I ran out of ham. In my previous slide, I put my KCl with my HNO3. Until I ran out of my KCl, I still have some HNO3 left over. Is that kind of making sense to you? Crickets. You know, guys, before we give up this Zoom thing, I swear to God, I'm going to get a recording of a cricket, and I'm going to somehow access it during these moments.
That would be fantastic.
Okay, guys, I've been at this about 50 minutes or so. What do we got? What more do you have for me? What more do you need to ask of me? Oh, crap. I just lost something. All that good hard work on that practice test just went away. Oh, well. Guys, if you've got nothing more, the dimensional analysis problems that are involved here are horrific. Example problem. Average density of whole milk is 1.03 grams per cubic centimeter. What's this density in pounds per gallon? Easiest way to solve this problem. Take the 1.34 grams, figure out how many pounds that is. Take 1 cubic centimeter, turn that into 1 cubic centimeters equal to 1 milliliter, which is equal to 1 liter over 1,000 milliliters. Turn it to liters, from liters to quarts, and quarts to gallons. So you're going to determine how many pounds you, or how many pounds you have and how many gallons you have, and just divide the two. If you don't have anything, guys, I think we're just sitting here wasting time. Do I have a motion for dismissal?
Yes.
Yes.
Do I have a second?
Yes.
Yep.
Yep.
Okay, unless you have something, unless you have a question for me, I'm just gonna go ahead and stop this now. You guys are seriously being polite there? You're seriously being polite.
Bit.
Let's see how many people are in here yet. I don't know how many people are in here yet.
I think it's been 12 pretty much the entire time.
12? Yeah.
Yeah.
Cool.
Okay. If you guys don't have anything more, bye-bye. I'll see you next week then, okay?
Thank you.
Bye.
Good
Have
night.
a good night.
Have a
Have
good
a-
night.
Thank you, Professor.
Take care. Take care, Ally.
Thank you very much.
Take care, Nathaniel.